In the vast reaches of space, there are perhaps 100 billion galaxies. Within the spiral arms of our own Milky Way, 400 billion stars. Spinning round our sun are hard and frozen planets, worlds of swirling, poisonous gas, and worlds whose rocky surfaces are barren and dead. Life becomes possible with precious liquid water, and it is abundant on just one planet, the blue planet called Earth. Perhaps it should be called Planet Ocean, for less than a third of its surface is above water. Beneath its charted waves is an amazing world of constant motion, shimmering light and liquid darkness, home to creatures great and small. In its depths are things never before seen, never imagined. To study the oceans of planet Earth, science must venture beyond the shore and beneath the waves. New technologies take researchers to deep frontiers and high into space to gaze upon the global ocean. With electronic eyes, they explore distant realms. Scientists and their machines of exploration have opened a world of fascinating connections. Satellites in space capture the seas in new dimensions and color the flow of a powerful current sailors try to cross. Researchers probe the ocean's interior without ever going there. A tropical reef in Panama is linked to a devastating drought in India. And a dive to the seafloor becomes a journey back in time to frigid blackness. Where life should not exist, strange creatures defiantly survive. In an ocean ancient and deep is a world newly discovered. A place of wonder that could only exist here on the blue planet called Earth.
Annenberg Media.
Corporate funding for Planet Earth is provided by IBM. IBM is proud to support the innovative spirit of scientific inquiry that made this series possible.
Ignition sequence started. All engines are started. We have ignition. 2, 1, 0. We have a liftoff. We have a liftoff, and it's lighting up the area. It's just like daylight here at Kennedy Space Center.
Night is turned to day as the Space Shuttle Challenger ascends from Florida's Cape Canaveral. In but a few minutes, it will be high above the planet, sailing the seas of outer space.
Okay, your log name is Paul Scully-Power.
Challenger carries researchers into Earth orbit in an unprecedented era of discovery.
Been observing the ocean throughout the flight, and we'd like
Oceanographer Paul Scully-Power, the first of his profession to witness the view from orbit, joins the astronauts and mission specialists.
coming along on this.
He observes and photographs large masses of spinning water called eddy fields. They show up in the low-angle sunlight as golden filigree on the ocean surface, 190 miles below. Swirling eddies are usually found close to major currents. These spirals of water in the open oceans are only recently discovered and not fully understood. They may coil and uncoil like giant springs, storing and releasing huge amounts of energy. Aboard the shuttle, Scully-Power makes the first oceanographic report from space.
For some years now, the astronaut crews have brought back photos of the ocean from space, and which sort of captures small areas. But when when you come up here, you see that all those small areas and all that dynamics are all interrelated. And for example, literally the whole of the Mediterranean is just one vast eddy field. It's spiral eddies all the way. And from this altitude, you can look down the Mediterranean and see the interconnections. And we're tending to see this sort of thing all the way around the world. And as I say, probably the best way of describing it is integrating the pieces of knowledge we've had into one big vista of the oceans.
For earthbound oceanographers, a picture of the global ocean is a great milestone. The interplay of its many parts is now viewed from a totally new perspective. At the surface, there are few clues to what is happening beneath the waves, but recent discoveries have revealed a link between the weather and the movement of the seas. As long ago as the 16th century, Leonardo da Vinci compared the behavior of Earth's atmosphere to water in motion. All the movements of the wind resemble those of water. The air moves like a river and carries the clouds with it, just as running water carries all the things that float upon it. Now, centuries later, events in the seas are thought to be strikingly similar to those in the atmosphere. Theories describe liquid storms the size of hurricanes and oceanic tornadoes churning the deep. The liquid ocean is dense and moves more slowly than the airy atmosphere, but its waters are in constant motion. There is weather in the sea. A landlocked mountaintop overlooking Boulder, Colorado, is the site of innovative studies. The National Center for Atmospheric Research. Here, computers, among the most powerful in the world, simulate the complex behavior of the Earth's atmosphere and oceans.
Okay, here now, it looks like we scanned through this too quickly to my eye. What would really be exciting is to be...
Oceanographer Bill Holland has asked meteorologist Richard Grosjean to collaborate on an unusual experiment. Scientists have often used the computer to create two-dimensional models, slices of the ocean, but now they try to see it as it really is, in 3 dimensions.
Between the upper layers and the deep ocean. Yes. It'd be awfully nice to make a 3-dimensional version. Well,
a scientist of the ocean uses a computer program developed to model the atmosphere. Holland examines a cube of the Gulf Stream, as if lifted out of the sea. As a jet stream moves across the sky, the body of the warm current rides over the surrounding water. Swirling water peels off the stream. These are the eddies. As they spin and corkscrew downward, some of them plunge thousands of feet to the sea floor. The computer-created view of the Gulf Stream is unique, but the movement of its current is not. It is but one of several ocean-borne phenomena that are like the weather on land. Aquatic versions of weather cross the ocean in internal waves. Benthic storms and hurricanes scour the deep. A spinning eddy in the sea is strangely like a tornado in the atmosphere. The power of the computer enables us to see the depths of the ocean as never before, and has unveiled an interior more turbulent and mobile than ever imagined. Like plaited ribbons fluttering in the breeze, the Gulf Stream arcs across the North Atlantic. At 60 miles a day, it carries nearly 100 times the water of all the world's rivers combined. The Gulf Stream is probably the most studied piece of ocean in the world. The story of its discovery is tied to colonial America. The first chart of the Gulf Stream was made by Postmaster General Benjamin Franklin to help speed the mail from England to the colonies. It traced the path of the current up the coast of North America and across the North Atlantic. Franklin included instructions on how westward sailing ships should avoid the current, while those traveling eastward could benefit from its flow. His map of a single river-like stream was remarkably accurate for its time, but it would take more than 200 years before another chart captured its true nature. At the University of Miami, researchers produce images of the Gulf Stream far more detailed than Franklin could have imagined. Using complex computer programs, Otis Brown and Bob Evans have recorded a portrait of the stream's course over several months. Their information is gathered in space. Sensors on orbiting satellites read the surface temperatures of the water far below. The warm waters of the Gulf Stream are marked yellow, meandering alongside the cooler blue waters of the North Atlantic. Spinning like a top, water breaks off to form eddies north and south of the stream. The Gulf Stream is a warm river whose banks are constantly changing. The push of its current and spin of its eddies can help or hinder all who try to cross it. Every 2 years, cruising yachts race to Bermuda from the Cape Cod town of Marion, Massachusetts.
Doing good. We're crawling up on them. Start it, would you? Start it. 8 knots to Bermuda, and we will be there very early.
For one of the boats, it is her maiden voyage. The captain and crew of the Replique will need all their skill and knowledge of the Gulf Stream to get to Bermuda before the rest of the fleet. In a reach down Buzzards Bay, the boats begin a 4-day ordeal that will take them across some of the most difficult water in open ocean racing. At the World Weather Center in the Maryland countryside, a close watch is kept on the Gulf Stream. Jennifer Clark of the National Oceanic and Atmospheric Administration receives the latest satellite maps and plots the movements of the stream. She draws the race course and will add special information for the racing fleet in her regular reports. These bulletins are important to all ships on the high seas, and especially to the captains of the boats bound for Bermuda. The stream contains a deep loop, a meander that doubles back on itself. If a boat can maneuver on the downriver side of the current, it will get an extra kick toward its destination. Though she is hundreds of miles from the fleet, Jennifer Clark's satellite maps and radio bulletins are the only help the racers will receive as they try to follow the changes in the stream. In this race, rules of sportsmanship prohibit use of electronic navigation. To calculate their position, the yachtsmen rely on the radio reports and the sextant, that centuries-old tool of mariners. Still many miles from the stream, each captain must decide his strategy and choose his course.
And there's our DR plot. Now you see we're coming into a small warm eddy where we'll get the reverse side and might get pushed back a little bit.
And we could miss it.
And we could miss it. Yeah.
Captain Harry Bush and his navigator gamble. They decide to try for speed by riding the stream as long as they can and perhaps catch an additional push from the spin of an eddy. Other boats will try a different strategy and take the shortest course across the current.
Look at those clouds near the sun.
Telltale clouds are a sign that the Replique is near the legendary River in the Sea. Temperature readings confirm their position.
We're about 25.5 degrees Celsius.
That's it? That's Gulf Stream.
Okay. It's worth it just for that.
In the stream, the crew of the Replique is confident the push of 3 knots will get them to Bermuda first.
Up she rises, way up she rises early in the morning.
The Gulf Stream and its eddies are ever-changing, and not all changes appear on the satellite maps.
Jim, I'm looking for that 2356Z satellite picture. Has it come in yet?
Yes, here it is.
Okay, thank you.
A warm core eddy to the north of the stream is visible from space. South of the stream, cold rings break off and slowly sink. While on the surface, they can be seen, but once they sink, they are invisible to the satellite.
Gulf Stream coordinates, north wall, 100 miles east.
Though the wind still blows and the boat's prow still appears to cut the waves, it is an illusion. Something unseen now slows the replique's progress.
This position here, we're at least 20 miles back. Therefore, my earlier sight must have been correct, and something is pushing us backwards.
Still, I don't know. I don't really know.
Well, there are powerful currents running out here that simply can't be tracked.
Aren't they all stream-induced, though? I mean, after all, the stream is a river in the middle of the ocean, and they all related to the stream,
Yeah,
I believe.
what it could be is below the surface, there's a cold eddy, and the surface temperatures wouldn't record it. But if it's down 5 feet, it could set us back, and there'd be no way from the surface temperature to recognize it.
What you're saying is we need a 2-foot draft boat, right?
Crew's frustration mounts as their chances of winning decline.
Oceanographers are in the same category with weather forecasters and stock analysts.
Thunderstorms through tonight.
The replique finally breaks free of the cold ring eddy. They are beyond the Gulf Stream, and the radio bulletin reports an approaching squall. Fighting through the storm, the replique roars down the final leg to Bermuda, and the news of how they fared against the rest of the fleet. The result of their wager will be known in a few hours' time. In the morning light, replique motors into the Hamilton harbor. The Gulf Stream gave them a strong push, but other boats are there before them. They are 15th across the line, but they arrived safely. Harry Bush finds that the wrong side of the cold eddy was a delay encountered by everyone who tried to stay in the stream.
It was apparently one of those cold eddies that's beneath the surface, and it's impossible through the means we have available to us to ascertain whether you're there, near it, in it, until you realize how much ground you lose to the eddy.
The skipper of the sloop Pirate won the race, even though he took his boat 110 miles west.
There was hardly any way to win and several ways to lose on it. So we went north of it and then crossed the stream, picked up about 35 miles perhaps from the stream, but didn't stay in it particularly long. We didn't maneuver to stay in the stream. We wanted to get on out to the west, and it seemed to work for us.
A gentleman's race ends, symbolic of our knowledge of the Gulf Stream. With satellite and computer, the mighty current in ceaseless motion has been captured in astounding images. Yet its twists and turns are as unpredictable as the outcome of a yacht race. The Gulf Stream is but one of several major current systems in the world's oceans, created by prevailing winds and the Earth's rotation. The Brazil, the Kuroshio, the Peru, the Australia. Mariners have long known and used these great currents to navigate around the world. But there are still other currents driven by temperature that run deep in the interior of the oceans. At the bottom of the globe, Antarctica is the hub of a wheel connecting all the oceans of the world. Computer animation records them turning around the icy continent in one giant circuit. The circumpolar current is the pump that drives all the cold Southern Ocean currents. In the polar regions of the Earth begins a journey that scientists believe holds the key to the circulation of deep water far below the surface. Scientists measure minute amounts of pollution and radioactive material in the water to trace the path of the currents. Heavy and dense, the cold water sinks. These deep currents can creep along the bottom for centuries. The trip across some ocean basins takes as long as 1,000 years. Eventually, internal currents resurface as upwellings. The cold waters bring the nutrients from the deep that make life possible in what would otherwise be a stagnant liquid desert. The frigid waters of Antarctica might be thought a wasteland, but it is the cold water currents that make life here especially plentiful. Here, as throughout the ocean, all life is linked by the food chain, that intricate geometry of eat and be eaten. From the most majestic whale to the littlest fish, it ties the destiny of one creature to another. Ultimately, it is a scheme of harmony in a realm of breathtaking beauty. At the base of the food chain, determining the survival of all creatures, are plants too tiny for the unaided eye to see. Delicately colored plankton. They are the grasses of the sea. Seemingly simple, they perform the miracle of photosynthesis, utilizing sunlight to transform carbon dioxide and water into free oxygen and carbohydrates, the fundamental currency of all animal life. Both microscopic creatures and great leviathans are totally dependent on these plants. In the most recent technology, these tiny plankton are studied not through a microscope, but by satellites in space. Sensors that measure chlorophyll actually record the amount of plankton in the water. Ground stations receive and process the information beamed to Earth. One such laboratory is at NASA's Goddard Space Flight Center in Maryland.
Concentrations in this gyre area are higher in the winter, which makes sense.
A NASA team working with satellite images prepared by the University of Miami is joined by biological oceanographer Jim McCarthy of Harvard University. Together, they have produced remarkable maps of the Atlantic seaboard in colors that reflect the concentration of plankton. The highest abundance of life is in red, close to shore. Further out to sea, where there are fewer plankton, it is blue. South of the stream, a cold ring, a small yellow spiral of life trapped in a desert of blue, warm water. North of the stream, the opposite. The center of a warm core ring holds little life.
In the last decade, one of the most exciting developments in ocean sciences has been the emergence of the capability to measure the distribution of ocean properties from satellites. This is done routinely for temperature, which shows the patterns of currents and the eddy fields that spin off of them. But recently, we have seen the development of the capability to look at large areas of the ocean and see the distribution of plankton, the distribution of organisms in the sea. We know that the distribution of organisms is related to ocean currents. We know that currents affect where the organisms are, but also that currents supply the nutrients from the deep ocean that permit these organisms to grow.
Through the grasses of the sea passes half the oxygen breathed by the animals of Earth. The fate of life on land and in the sea is bound to the well-being of these microscopic plants. Some tuna migrate 200 miles in a day. In a year, they can circle the Pacific Ocean. Wherever ocean currents carry the plankton, tuna will follow. Today, the fisherman is receiving help from a technology that never goes to sea. Mike Lowers of the Southwest Fisheries Center in San Diego gives fishermen a good idea of where they might find tuna before they ever leave port. He uses plankton maps made from satellite data.
This is an ocean color image measured by satellite. It shows areas of the ocean that are very rich and other areas offshore that are more clear. Tuna are visual feeders and consequently need rather clear water in order to detect the food organisms they eat. So they aggregate along these boundaries between the clear water and the more turbid water. Obviously, this sort of information is very important to fishermen who are seeking tuna.
Satellite and computer have fashioned a map of currents and life intertwined. In ancient times, a poet asked, "Who can fathom the depths of the wine-dark sea?" Now we have gained a new glimpse of those dark waters that stretch far beyond land's end. We can read the signature of life written in the oceans of this blue planet. The cycles of weather on Earth are linked to the seas. Many environments on land owe their predictable weather to the regular temperature and flow of ocean currents. But when the constancy of the ocean is disturbed, the seas can produce disaster. In the winter of 1982, a series of catastrophes struck widespread parts of the world. Raging surf battered the California coast. For the first time in 75 years, hurricanes roared down on Tahiti. In 5 months, the island was lashed by storms 6 times. A severe drought struck southeast Australia, producing gigantic dust storms. In their wake, the worst bushfires in the nation's history marched across the land. In Africa, the winter rains did not come. There was no relief for the dry, parched ground. But half a world away, a record snowfall in Utah produced unprecedented spring floods. Streets became rivers of mud. Reports were relayed from Africa to Asia to the Americas. The damage cost $40 billion. A clue that might link all of these events is to be found off the coast of Panama. For 15 years, the coral reefs of Uva and Sika Islands have been a laboratory of study for scientists from the Smithsonian Tropical Research Institute. Peter Glynn and his colleagues have now refocused their studies to determine the cause of a deadly mystery on the reef. These reefs are a microcosm of life on Earth. Thousands of species living together, all of them dependent on a type of plankton that live in the coral. But early in 1983, disaster struck here as well. During the same period in which weather went wild on land, the symbiotic plants that live inside the tissue of the coral died and streamed off. In places, the reef is beginning to recover, but great parts still remain devastated. Studying its rebirth, Glynn is looking for the cause of the coral's death. He first suspected that the destruction was triggered by man-made pollution. Once the die-off had begun, the crown of thorns starfish moved in to further decimate the coral. The feisty little guardian shrimp that normally protect the reef could not stop them. But there was little evidence of pollution. Something else had attacked the hardy reef, perhaps an abrupt temperature change. A temperature change could be connected to El Nino, a warming trend known to disrupt the waters off Peru. There, warm waters raise the temperature above the tolerance for life. After measuring the temperature of the surrounding water, it seemed a theory worth testing in the laboratory.
We have an example here of a tank where the water temperatures are about normal, and you can see in this coral that it is golden brown in color. It has plants that live in the tissues symbiotically, and this is the normal situation with normal seawater temperatures. Now, in 1983, the seawater temperatures were higher than normal for 2 to 3 months. We have duplicated the warming conditions, and you can see that the brown color has left the coral skeleton, and we still have a little bit of the normal coral on top, but considerable bleaching and loss of the algae below. We are probably duplicating the coral bleaching and death that we actually observed in the Eastern Pacific Ocean during 1983.
Glenn and his team returned to the reef. Coral grows outward like trees. Only the surface is alive, and beneath it is layer upon layer of earlier generations. In the towering coral heads, some of them 400 years old, there may be a record of past catastrophes. Glenn now believes that El Nino is the cause of the devastation. If so, the samples taken from the coral should match the history of past warming events. And the pattern of the past may be a clue to when El Nino will next come to the reef. El Nino, the child, so named because the warming event is observed near Christmas time. Though recorded for nearly 200 years, its cycle is highly irregular. Scientists are only now beginning to understand its basic mechanics. Instruments aboard a satellite can read the changing surface temperature of the ocean, including the waters off South America. Off Peru, there is a rich upwelling of cold water. But every few years at Christmas time, a layer of warm water thickens in the eastern Pacific, cutting off the nutrient-rich water in which plankton live. They die, and the entire cycle of life breaks down. A satellite study of El Nino has been conducted at the Scripps Institution of Oceanography. Robert Bernstein, plotting the surface temperature of the ocean, has pieced together a map from 1982 and 83. His study covers the entire Pacific Ocean. On the monitor are 2 maps of the Pacific. Normal conditions for December are above, the El Nino year below. Temperature is shown by color, blue and green the coolest, orange and red the warmest. The upwelling is a tongue of cool blue water that extends outward from the coast of South America. But in 1983, it is capped and snuffed out as the water temperature rises as much as 15 degrees Fahrenheit. These unusual conditions are not confined to South America. Far to the west, there have also been dramatic changes. Some disturbance has occurred between the sea and the air in the western Pacific, and weather in the ocean and the atmosphere has shifted eastward by a full hemisphere. The dramatic disturbance is reflected in the atmosphere. Satellite photos above the Pacific show how the normal cloud patterns of the trade winds break into disarray. Scientists realize these fluctuations are far larger than just a warming trend off South America. These oscillations in the Southern Ocean are even connected to the monsoons in Asia and play havoc with the weather of nearly 70% of the world. In late 1984, an international symposium is convened in Paris. From around the world, scientists come together to sort through the global implications of the discovery.
On the other end. And that's a major project. Australia had some very severe droughts, in particular in places which normally don't have drought.
In the Philippines, the El Nino has done a devastating effect very recently when 2 typhoons passed through the country within a period of 10 days that devastated the country and cost millions and millions of dollars.
All the major droughts in India, in fact, some of the major famines in India, they all occurred during the El Nino years.
A decade of research begins to explore the intricate connections between the ocean and the atmosphere. The goal, to learn how and when air and sea go out of balance, and to predict when it might occur again, before another massive El Nino strikes. The study is named TOGA, Tropical Oceans and Global Atmosphere. The research vessel Discoverer embarks on the first voyage in a decade of study that will involve over 50 countries, hundreds of vessels, and thousands of researchers. Because of its huge size, oceanographic information on the Pacific is far from adequate. TOGA promises to add dramatically to the knowledge scientists now have of the globe's largest ocean. Data recording buoys that radio information to land will be stationed across the Pacific. The weather of the atmosphere changes daily, but the ocean has a memory. Its weather may continue over months or years. Researchers will investigate just how one affects the other. A buoy is launched, and the most comprehensive study of how the oceans and atmosphere interact begins. Floating sentinels in the Pacific may shed light on events that affect the lives of millions, and scientists may discover that ocean and atmosphere are one continuous system, from the top of the sky to the floor of the deep sea. In legend, Alexander the Great was lowered into the depths. Inside his crystal sphere, he became the first traveler to observe the wondrous and strange creatures that inhabit the ocean. In this century, the trip was repeated by inventor Otis Barton and zoologist William Beebe. Their bathysphere was made not of crystal, but steel. From more than 1/2 mile deep, the explorers described fantastic fish that live at the edge of perpetual darkness. Unable to photograph what they saw, they relayed their descriptions to an artist on deck. The paintings appeared in the pages of the National Geographic magazine. Life forms seen for the first time. Fanged and luminescent, they too seemed like creatures born in legend. Today, ships of inner space allow scientists to probe deeper yet into the netherworld of the mid-ocean. Richard Harbison of Woods Hole Oceanographic Institution prepares for a dive in the Johnson Sea Link. Aboard this 20th century version of Alexander's crystal sphere, he enters the environment of the creatures he is studying, the animals that live in the midwater of the ocean.
The midwater environment is the largest environment on Earth. If you consider that 2/3 of the surface of the Earth is covered with water at an average depth of over 2 miles, you can get some idea of the immensity of this environment. It's a very different environment from the one that we know. Below a depth of about 400 meters, there's no light. The temperature is relatively constant, where for an animal living in this environment, there's essentially no boundaries between the surface and the bottom, and move 3-dimensionally in limitless space. It is also the least explored of all the environments on Earth.
With no one else to take a souvenir snapshot, Harbison turns the camera on himself and the pilot to commemorate the 1,000th dive of the Johnson Sea Link. There are animals here recognizable and familiar, but like Harbison, they are intruders from above, briefly visiting this realm.
Isn't that great? What a cooperative squid.
More astounding than Beebe's paintings, the inhabitants of this vast darkness are creatures of delicate, translucent beauty. Some grow to be 20 feet in length, but most are no larger than a human hand. Perfectly adapted to this environment of almost half a ton of pressure per square inch, many of them will disintegrate if brought to the surface. Only here can they be observed.
Why don't we catch him? All right.
A ctenophore drifts for the camera, its red food-gathering tentacles drawn into its body. It has never been seen before.
The lobes spread. He's actually coming back to shape quite nicely, which is good.
A medusa, an ethereal deep-sea jellyfish. A siphonophore is rediscovered. It has not been recorded since it was first found more than 100 years ago. Most are creatures new to science. Out of 30 specimens collected, half are seen for the very first time. It was known this world is vast. It was never believed it could be so full of life. Sound has been called the light of the sea. It is the equivalent of vision for the inhabitants of the watery world. Fish call and marine mammals sing to communicate and navigate. Scientists now think that whales are able to hear other whales across entire ocean basins. Imitating the songs of the creatures of the sea, man-made echo sounding was first used in the 1940s to behold what human eyes could not, the bottom of the ocean. Reflected sound waves bounced off the seafloor reveal an ocean bottom far different from the flat, muddy plain that was assumed to be there. Like Chinese ink drawings, there emerged mountains and ridges, valleys and plateaus. Then, in the 1960s, Bruce Hazen and Marie Tharp of the Lamont Doherty Geological Observatory assembled echo-sounding data from around the world. They set about to create the first comprehensive map of the world's ocean floor. It was a monumental task that could easily be compared to the cartographers of centuries past who constructed the first maps of the New World. Their revolutionary maps portrayed a remarkable geography. Among the discoveries, the world's tallest mountain became not Everest, but the island of Hawaii, reaching 35,000 feet above the seafloor. Perhaps the most curious feature revealed was a long, sinuous valley bordered with high ridges that wrapped its way around the globe. The Grand Canyon, among the visible wonders of planet Earth. 2 miles beneath the ocean surface is the mid-ocean ridge, similar in shape to the Grand Canyon, but over 200 times as long. Winding across the bottom of all the world's oceans, it is the largest geological feature on the planet. At the Exxon Production Research Company in Houston, Texas, an image processing laboratory becomes the stage where data from the seafloor is transformed by computer. Bill Ryan and John Farr are creating the first version of what one day may become a common way to explore the ocean.
We're looking at the East Pacific Rise in North Equatorial Pacific. This is a place where seafloor is actually being formed today. Essentially, we're using sound for eyes. We're looking at large pieces of the seafloor, 3 by 5 miles.
This visible portrait of the East Pacific Rise off Mexico is based on the maps of ocean bottom made by sonar. Using two different sets of advanced sonar information, the computer creates a single three-dimensional image. Sound transformed to light outlines a small extinct volcano. It stands about 60 feet high. To its right is the Rift Valley itself.
That's perfect right there. Place the camera down there in the
The computer becomes a camera positioned at will. Electronically, it captures the panorama of a pitch-dark world 2 miles beneath the surface.
Let's get about 300 meters above the seafloor. And vertical exaggeration of, let's try 10.
Okay.
Here we are. We're just going to leave the sea surface and gradually descend down and fly across that volcano there with the Rift Valley in the background.
The first ever to take this trip, we fly over the volcano and bank to the south and descend into the valley. Here, thousands of feet beneath the surface, new ocean crust is being formed. The Rift Valley is located at boundaries where the Earth's great tectonic plates pull apart. In the deep sea, molten rock from the Earth's interior rises through fissures and cracks to become the youngest part of our planet's surface. Carried by the movement of the Great Plates, this new seafloor will eventually cross an entire ocean basin, and over millions of years, it will accumulate a record of its journey. West of Greenland are the remote Arctic waters of Canada's Baffin Bay, free of ice just a few weeks a year. The drill ship Resolution, taking advantage of the brief weather window, begins an extraordinary study. The Resolution is specially designed to probe the history that lies buried at the bottom of the sea. Funded by 5 nations and staffed with an international team of scientists, the Resolution continues the work begun by the first scientific drill ship, Goddard Challenger, in the 1960s. The sediments of the deep provide a unique portrait of what our ancient Earth and sea were like. Embedded in the ocean floor is everything that lived in the water or washed from the land in the past 200 million years. From thousands of feet beneath the seafloor, cores of geological time long buried are returned to the surface. In the shipboard laboratory, they are analyzed and recorded by the most advanced tools of science. One by one, they yield up their secrets. Magnetic particles help reveal the age of the core and the ocean basin beneath it.
Interglacial.
In layers of sediments is chapter after chapter on climate and ice ages. They are a diary read by scientists Mike Arthur and Surat Srivastava for clues of when these waters were a tropical ocean and when they were covered by sheets of ice miles thick.
You can really see the interglacial sediments are light colored and the glacial sediments are dark colored. That's right. Those are characteristics.
The electron microscope focuses on the skeletons of minute animals.
That's really well preserved.
Eons old, they reveal a tale of the temperature and chemistry of an ancient sea, and even of the abundance of life on an ancient Earth. Cores are stored to be sent to laboratories on land for further study. Eventually, they will be collected from every ocean on Earth. Each core is a unique history book, and volume by volume, they are added to the library of discovery about the distant past of the blue planet. deep diving submersible named Seacliff rides aboard a United States Navy tender in the blue waters of the Pacific. Following dramatic discoveries made by her sister ship, Alvin, Seacliff and other deep diving vehicles take scientists to explore the bottom of the sea. Seacliff carries a crew of 3 in its cramped 5-foot sphere. Inside, the co-pilot sits upright. The pilot and scientist lie prone, positions they will keep for the duration of the dive. It can descend to 20,000 feet, deeper than any other research submarine. It will be 9 hours before Seacliff returns to the surface.
Co-pilot, trim satisfactory. Commence bottom approach.
Transquest, this is Seacliff. Mike depth, 4075.
The scientists are searching for a vent area, one of the most exciting discoveries about the sea floor. In a world without light, sonar guides them to the location they seek. On the bottom, at the boundaries of tectonic plates, are cracks created by the pulling and tearing of geological activity. This is a domain of unrelenting darkness, where only immense pressure and the salt in the water prevent it from freezing. In this frigid world, hot water gushes out of the sea floor. Water seeps through the cracks in the bottom. Heated by the Earth's interior, it returns to the ocean through these vents. Each hot spring is an oasis of life in the deep. Strange creatures abound. Tube worms more than 2 feet long with no mouth and no stomach. 2 miles beneath the surface are giant clams the size of salad plates and albino deep-sea crabs. At the heart of this alien world are bacteria that live in the scalding hot water and feed on substances normally poisonous to life. Most extraordinary, in this pitch-black world, they actually create organic carbon, playing the role sunlight performs on the surface. Scientists now think a hot spring is born and dies within a few hundred years. How these creatures endure the frigid water to find a new home remains a mystery. Communities of paradox, they challenge our basic ideas of where life begins and how it evolves. Seacliff returns to the surface, a ship of the deep with tales from far frontiers. With instruments of exploration, science has found a new ocean, an ocean responsible for much of what is remarkable about planet Earth. The drama of the land on which we live begins at the bottom of the sea. From the furnace of the deep comes the fiery stuff of which our planet is made and remade. From its currents stems much of Earth's weather, the duet and counterpoint of sea and sky. The ceaseless flow of ocean waters and the wind of Earth's atmosphere are partners. Like mirror images, they wrap the globe in constant motion. Our many pictures of the sea are made by sound, imaged by satellites, processed by computers, and finally witnessed by human eyes in a way that was never before possible. For centuries, its surface was opaque, and our knowledge stopped with its shore. Today, we venture beneath the waves, and what we discover is more fantastic than ever imagined. Our journeys into the deep seem like visits to another planet, but in fact, it is a trip further into the heart of our own. At last, science has begun to see Earth as the blue planet, a fresh perspective that challenges us to search the seas anew. A new journey has begun, echoed by the genius of Sir Isaac Newton. All this time, I seem to have been only like a boy playing on the seashore, while the great ocean of truth lay all undiscovered before me.
Annenberg Media. For information about this and other Annenberg Media programs, call 1-800-LEARNER and visit us at www.learner.org.